Hello dear students, so far we have discussed how you can maximize your Sharpe ratio by using the solver function of MS Excel software, and so far we have discussed many complicated techniques, and at this stage we want to show you how can you draw the graph. Actually, in the efficient frontier, that is a graph that we need to determine in order to find uh, the portfolios that contributes as for a given risk maximum return, or for a given return minimum risk. So now we will discuss about the techniques by which we can able to draw this efficient frontier graph. So here you need to add some extra column row. So this is your RP. Okay, it will be your RP, and then standard deviation, then Sharpe ratio. Here we will show the company name W X Y Z. Actually this 4 row, this will tell about the weight. So we have already find out this value, that is Sharpe ratio. That is the maximum Sharpe ratio 300.93, or you can say 301. This is the maximum Sharpe ratio. That means it is your maximum return, that is 7.44%. So you know what is your maximum return. Actually it is not percentage nice yet. This will be your percentage value of return of portfolio. So %7.44%, that is your maximum return of the portfolio. Now we know at this return the standard deviation of portfolio is 2.45% or 0.0244. So we know what is your maximum return, but we didn't find out what can be your minimum risk or minimum standard deviation. So here there are several cells. So at the first stage we will put this value that we have gotten earlier by maximizing Sharpe ratio. So Sharpe ratio, it is 300, and at this stage return of portfolio is 7.44. so we copy it and paste here. If this comes here, then just click here and select values only. Okay, this is the similar value, and at this state the standard deviation of portfolio is this one. So again paste. So you need to change this value, and at this stage the Sharpe ratio is 300 and something values only. And what is your weight at this stage? So this is your weight. Okay, this is the similar value. Now we will use the formula to determine the minimum variance of the portfolio, so that we can say that a global minimum variance. So again go to the tools option, then solver, okay, so go to the tools option, then solver. So what is your target cell? Your target cell is now it will change because you want to find out the minimum standard deviation. So set your target cell to this one, standard deviation of portfolio. Okay, this one is your target cell. By changing cell, okay, so your target cell is standard deviation equal to minimize, so it will be min. By changing cell, by changing your weight, so this is your weight cells. Okay, and here is the constraint. So your first constraints you need to add. So put the cell reference equal to the sum of weight, that is this one, and this should be equal to 1. Press enter, we got this value, and now click the solve button. Solver found a solution, press OK. So you see now your standard deviation that is now 0.018 something. So this is your minimum standard deviation or global minimum variance, and at this stage your return of the portfolio would be 4.25. okay, so copy this one, paste here, standard deviation, copy it here, paste here, and you see your Sharpe ratio is something to 26, and at this stage you can get this return with this standard deviation if you put your money in these 4 securities at this proportion. Okay, so as this is with short sales, so this minus figure means you can disinvest it, that is short selling of jet security, and you need to invest this 3 security WXY at with this proportion. So copy it here, paste here. Okay, this similar value. Now you see your global minimum variance is starts with this return and this standard deviation, that is global minimum variance, and that ends with this maximum return, while standard deviation is this one. So in order to draw this figure you need to put some more values here also. So take different value that is between 4.24 and 7.44, so any value higher than this one but lower than this one. Okay. So for example at this stage we want to take our return portfolio is 5, this target. So if your target return is 5%, so how you can achieve this return? By minimizing your risk through optimal allocation of resources in different securities. So this is your target return. Okay, so you need to put another cell here that is called target average return. So so our target is 5. Okay, so as we have added new condition, so at this stage you need to add another constraint. So go to the solver option, this will be as before same, but you need to add some extra constraint, so add here. Okay, so your cell reference, that is, so your cell reference will be your return, that will be equal to the your target average. So this one, it will be equal to, what is your constraint? Your target return. Okay, so this one is target return. Press enter. So new target value have been added here, and press solve. Solver found a solution. Okay, so we have already set our target to the 5%, so we put this value here, and at this stage our standard deviation will be this one, and our Sharpe ratio, it also increases slightly, and we can achieve this target return and with this standard deviation if we allocate our resources in these 4 securities at this proportion. So we'll take another 2 values. So next calculate 6.5. so just change it here, 6.5. this is target average, we have increased it here. So go to the solver. So you don't need to adjust here because you already have put different value here, so it will calculate it automatically. So just click solve and press OK. Here you see at this stage it got a new standard deviation, and this is the Sharpe ratio, and this is your weight. Okay, and we want to put here something like 7%, 700% actually, and so set your target is 7. So click tools, solver, again solve. So you see your standard deviation has changed. Sharpe ratio has changed also, and to get this return you need to distribute your fund proportionately with this weight. Okay, so you just need to plot this return standard deviation in the graph, so you will be able to draw the efficient frontier. One interesting thing I can share that after this Sharpe ratio, what you have got earlier, that is your maximum return. So if you increase this return further of this point 7.44 higher than this value, then your Sharpe ratio will decrease. So you will stop when your Sharpe ratio will be maximized, and we have done here. For example, if we set our target average is 8%, okay, 800%, so that is your target average. So now if we want to solve it, what we got here, okay, so at 8%, for example, you see your standard deviation is this one, but your Sharpe ratio has decreased. Like previously it was 300.93, now it has decreased to 299.96. so take another example like 9, then solve, it has decreased further to 9 at 9, target it has decreased to 295. Okay, 295. So that means you have to stop here when your Sharpe ratio will be maximum. So we have already found out earlier. Okay, so delete this value. So we'll want to plotting this in a graph. So little bit change here, format cells number 2. Okay, okay. So go to the chart option, chart wizard, and you need to draw a scatter graph. Okay, there are different type of chart, so this is scatter. So among scatter, draw this one, is scattered with data points connected by smoothed lines. So it will connect the lines automatically. Next, in the series options, add your value. Okay, so the name we know, efficient frontier, this is your name. X value means your horizontal value, and we know we put standard deviation in the horizontally, so your X value will be this one, standard deviation. And Y value, that is vertical value, and we put the return in the vertical axis, so this one. Press next, here x-axis, that is mean standard deviation, and y means return. Okay, press next, press finish. So you see the efficient frontier has been drawn here, you see there. So here at this point, this is the global minimum variance, and this is the maximum return, and this is the different point, that is the target return. So in this way we can easily drop efficient frontier. Now question may arise, what will be done in case of without short cell. Actually the process of with short cell and without short cell will be the same. There will be one difference, and that is you need to change your constraint, or you need to add further constraint that we have shown earlier. The constraint is this weight should be greater than or equal to 0. Okay, so that's the constraint. So this is the second scenario. Okay, we have changed Excel file. This is the second scenario, that is without short cell. Previous one is with short cell, and now without short cell. So no weight should be negative. This result we have already find out earlier. So at this stage we'll go as the previous process, but additionally we have to put another constraint. Okay, so let's start this result. We have already find out our Sharpe ratio will maximize to 197. So put value here. So at this stage your return of the portfolio will be this one. So that is maximum, so you cannot go further of this value, and your standard deviation will be this one, and the weight will be like this. Okay, so now first we want to find out the global minimum variance, then we'll set our target return and we'll go further. So go to the tool solver, your target cell is this one, standard deviation. It should be minimum by changing weight, so this cell, while your common constraint that your cell reference is sum of weight, this should be equal to 1. Press enter, we got this one. So for not short selling you need to add further constraint. So let's start. So add, your cell reference will be first weight, it should be greater than or equal to 0. Press enter, then add cell reference is second weight, this should be greater or equal to 0. Then add your third constraint, that is third weight, it should be equal or greater than 0. And last one, last weight, this should be greater or equal than 0. Press enter. Okay, you got here. Now just press solve button. Solver found a solution. Press OK. So you see your global minimum variance portfolio, that value will be this one, standard deviation, and at this level your return of the portfolio will be this one. Actually there is not much chance of return of the portfolio, that is 3.61, it is 3.94. actually we have done with hypothetical value. By using real data you will get more rigorous result, more what is eye-catching result. Okay, so Sharpe ratio, while your weight will be this one. So now at this stage you need to set your target average. So set your target average equal to something like 3.61, so 3.75. so you know the rules. Go to the tools option, solver, so new constraint will be added here. So what is your cell reference? Your cell reference is return of the portfolio, this should be equal to your target return, this one. Okay, add here and solve. Okay, so at this stage standard deviation will be this one, and Sharpe ratio slightly increased, and this is your weight. Okay, all says you need to disinvestment security just, and we'll set our last target average, that is 3.9. go to the tools option, solver, so it will automatically take this value. So solve, press OK. So at this 3.9, that is your return of the portfolio, and standard deviation is this one, and your Sharpe ratio has increased slightly, 197.35. your maximum Sharpe ratio is 197.50 because you cannot go further after this point, and this is your weight. So we need to put this value into the graph. So go to the graph, scatter graph, okay, add series. Your title of the graph is efficient frontier, and your x value that we have already discussed, x mean horizontal, so your horizontal you put your standard deviation, so this one, and y value, that is your return. Press next. X is your standard deviation, y is your return portfolio, okay, RT. You see, we have got here efficient frontier. How simple is it? So this is the global minimum variance and this is the maximum return, okay. So in this way we can draw this graph. So first it starts from finding out the return of the individual security and standard deviation, then constructing covariance matrix, and then you need to find out maximum Sharpe ratio, and then the last process we have discussed, this will be used to determine the efficient frontier. Hope you will benefited from this learning, and I'll be ready for further instruction. Best of luck.